So in this video, we're going to look at a problem from proof by contradiction, which says that if a square is even, then a is even. Okay, and so let's assume I've got some statement P out there, which is logically equivalent to saying if Q then R. Okay, and in this case over here, I've got a square is even being R, being Q. That's what my Q is, and my R over here is A is even. Okay, so given this statement P here, and using proof by contradiction, so what I'm going to do is I'm going to assume that the negation of P is true. So before I prove that the negation of P, or before I show any contradiction by starting from the negation of P actually being true, let's just write what negation of P looks like given this given what P is. So this is what P is. Then negation of P is equal to saying Q and not R. Okay, so assuming that not P is true. Okay, if I assume not P is true, then that tells you that this box over here must be true as well, which tells you that Q, because of the conjunction, Q must be true, and not R over here must also be true. Okay, so what is Q here? Well, Q over here is the statement that tells you a square is even. And not R, which is also true, tells you a statement that a is odd. Now, if the number a is odd, well, that tells you if a is odd, a can be written as 2k plus 1, where k is some integer. Every odd number can be written as 2k plus 1, where k is some integer. Okay, so if I square this, that gives you a square equals to 4k square plus 4k plus 1. And again, if I rewrite this by getting 2 out as common, that gives you 2k square plus 2k plus 1. Okay, so with this thing over here, it implies that a square is actually odd. And the reason it's odd is because what I have over here is this piece over here. K is an integer, and integer times 2 is an integer, plus k square, which is an integer, times 2 is another integer, and integer plus integer gives another integer. So this entire piece in yellow is an integer, right? So I've got 2 times some integer plus 1, meaning a square is actually odd. So this is what I've concluded. And which is in contradiction. It happens to be in contradiction to what I have over here, which is my Q, where I'm saying a square is actually even. So with this contradiction, I can say that the initial assumption of not P actually being true is actually false. This is false, which also implies that P must be 1. Now, one thing that I would like to at least point out over here is that though I'm claiming this to be a proof by contradiction, but it also happens to be identical to proof by contrapositive. Now, keep in mind that in contrapositive, what we have been doing is if I have a statement that I'm trying to prove where if Q then R, well, this entire piece over here is also equivalent to saying not R. If not R, then not Q, right? And by starting with not R, by starting with the statement not R, I have come to not Q, which is this piece over here. Because if Q is the statement a square is even, then not Q is the statement tells you that a square is odd.